fundamental principles of counting. So we have basic principles of counting, and entire permutation and combination concept is actually based on this fundamental principles of counting. Okay. So we have two basic principles. So the first one is principle of addition, and the second one is multiplication principle. Addition principle, and the second one is multiplication principle. So what does this mean? When a given task can be divided into multiple subtasks, when the given task can be divided into multiple subtasks, two or three subtasks, or if you have multiple tasks to be done. So in all these cases, you will get intermediate answers. And what you have to do with that intermediate answers, do you have to add it or do you have to multiply them? So that basic understanding comes through our addition principle and multiplication principle. So what is addition principle? If you have two tasks, so we are going to compare, we are going to discuss this with two tasks. The same is applicable for more than two tasks also. So if we have two tasks, T1 and T2, okay, if we have two tasks, T1 and T2, and T1 can be done in M ways, and T2 can be done in N ways. Okay, there are two tasks, T1 and T2. T1 can be done in M ways and T2 can be done in N ways. Then task T1 or T2, T1 or T2 can be done in M plus N ways. We'll see with an example, then you will understand it clearly. So basically, if you use the word or, then you will have to add the intermediate results. Okay, so whenever you have sub answers, when you have intermediate results, if you are connecting those tasks using the word or, then you will have to add the intermediate results, and that is addition principle. And what is this multiplication principle? Here also we will have these two tasks, T1 and T2, and T1 can be done in M ways and T2 can be done in N ways. I am not writing detailed statements here. I will share notes for this in the Telegram channel. If you have not yet joined our Telegram channel, I'll mention the link to that channel in the description so you can join. I'll post notes for these things where we have proper textbookish definitions. Right now I'm just trying to simplify the concept for you. So if you have two tasks, which is under multiplication principle, if there are two tasks given like this, and then both T1 and T2, T1 and T2 both can be done in M into N ways. So it's called principle of products or multiplication principle. Both are same. So here, if you observe, we are using the word and, right? So if you are using the word and, then you will have to multiply the intermediate results. Now, what do you mean by this adding or multiplying and using the word or using the word and? So we'll take an example for you to understand. So basically, suppose we have a student going from home to school. Okay, so let us take two examples. First example is a student is going from home to school, and there are two ways, like either he can go by bus or he can go by auto. Okay, so a student goes from home to school, and he can choose Either he can go by bus, and let us assume there are 4 bus routes. Okay, and then or he can go by auto, or I'll take 3 auto routes. If he decides to go by auto, there are 3 auto routes. Now this becomes your task 1, that is going in bus is task 1. In how many ways he can go in bus? There are 4 ways. There are 4 different bus routes. He can choose any of them. And this is T2. That is, what is the task? Either he can reach school from home in 3 different auto routes, right? So here there are 2 different possibilities. That is, he has to go from home to school, but then he can either choose bus or he can choose auto. Here he can reach the school. Okay, he will reach the school by bus or auto, isn't it? So we are using the word bus or auto in how many ways? 4 plus 3 ways, which is 7 ways. Means there are 7 different choices for him to reach from home to school. If he wants to go by bus, there are 4 different choices. If he wants to go by auto, there are 3 different choices. So there are 7 different ways of him reaching from home to school. That is your addition principle. So if you have multiple possibilities, or if you have multiple tasks, if you have to follow either this or that, in that situation, you're going to add them. That is addition principle. Now let us modify this example. Okay, example 2. Let us assume the student has to go from home to school. But here this journey is divided into 2 parts. Okay. So first part of the journey, he must go by bus. There is no auto from home to this point. Let us assume that. And there are 4 bus routes for this. Okay. After reaching this point, from here to school, there are no buses. He must go by auto only. Let us assume that way. And he has 3 different auto routes to reach from this point to the school. Now, he cannot say, I will go only by bus, or he cannot say, I'll go only by auto, right? He has to choose both bus and auto. Here, how many ways are possible to reach the school? Number of ways to reach the school is 4 into 3, which is 12 different choices that he has. What do you mean by this 12 different choices? So let us take this 4 bus routes as B1 to B4. Now he can choose B1 to go from this point to this point, and then he can choose A1, that is auto 1, to go from this point to this point. Or he can take B1 and auto 2, or he can take B1 and auto 3, or he can take B2 with auto 1, B2 with auto 2, B2 with auto 3. So like this, if you write 3 different auto choices for each of the bus, you will get 4 into 3, 12 different uh, possibilities like this. So that is your multiplication principle. So basically what you have to do is, whenever you have subtasks, just think, is it this or that, or it is both this and that? Accordingly, you will decide whether you will have to add the intermediate answers, or do you have to multiply these answers. So this is your basic fundamental principles of counting, which is addition and multiplication principle. There are some simple problems which you can solve without actually using permutation or combination formulas, with just this basic principles of counting. All the formulas that you have under permutation or combination are basically derived from these principles only. Okay, so this is the first information that you need to know under permutation. So the next one that you need to know before we actually start solving permutation problems is factorial. So factorial of a number. What is factorial of a number? I'm sure if you are a computer science student, then you would have written programs to find out factorial of a given number, right? How do you find factorial of a number? We express it as n factorial, which is equal to n into n minus 1 into n minus 2 up to 1. It is product of all numbers from n to 1 or 1 to n. That is factorial of a number. And by definition, 0 factorial is equal to 1. Now, when I write factorial of a number, so 0 factorial is taken as 1, 1 factorial is 1, 2 factorial is 2 into 1, which is 2, and 3 factorial is 3 into 2 into 1, which is 6. So here, if you observe, 2 into 1 can be written as 2 factorial. Right? But 4 into 3 into 2 into 1, I can write 3 into 2 into 1 as 3 factorial. So now we know 3 factorial is 6. So 4 into 6 gives you 24. Okay, so once you know factorial of any given number, you can find out what is factorial of the next number by multiplying a number with its previous factorial. So write down these factorial values which are useful for you to in solving many questions. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, 7 factorial is 5040, and 8 factorial is 4320. Okay. So these are the standard values until 8 factorial. If you know, it is more than sufficient. Beyond this, if you have any values for which you need to find the factorial, you can always use these things, or you can even keep the solution as it is if it is beyond 9 factorial. Now this is factorial of a number. Now we'll see how to simplify expressions or mathematical statements which has factorials. Let's solve this with two examples. Suppose you have to divide one factorial by the other. Say you have 10 factorial divided by 8 factorial. Here, we will not actually find out what is the value of 10 factorial. Instead, we will always expand whatever is a bigger factorial, we will expand it until we get the smaller factorial. So here for 10 factorial, I will expand it as 10 into 9 into 8 factorial divided by 8 factorial. Now 8 factorial gets cancelled and you're left with 90. Similarly, suppose we have 7 factorial by 4 factorial. Can you tell what is the answer for this? Mention in the chat what is the answer for 7 factorial by 4 factorial. You need to expand 7 factorial until you reach the smaller factorial. So 7 bigger one we have to expand. So let me take 7 into 6 into 5 into 4. So we will stop it here because we have 4 factorial in the denominator, which gets cancelled. So we have 30 into 7, which is 210. So this is how you simplify any statements, any steps which has factorials. Now we will start what is permutation. We'll start with the definition of permutation. So you have now learned whatever is a basic information required for permutations and combinations to learn this topic in general. So one is addition and multiplication principle, and you know how to find factorial of a number, and you know how to simplify expressions which has factorials. So now what is permutation? So permutation involves selection and arrangement. Okay, it is selection and arrangement. Remember this. So the basic confusion between permutation and combination can be cleared if you know whether a position is important or not. So if a position is important, if ordering is involved, if arranging is involved, then that comes under permutation. If we have to just do the selection, then it comes under combination. Now, what is permutation? It is selection as well as arrangement. So, number of ways or number of ways, please write down this definition, number of ways of selecting and arranging. Selecting and arranging are objects out of n distinct objects. Are out of n distinct objects is called as the permutation. So here there are certain things that you need to observe carefully. So we have n distinct objects. There are n objects and all of them are distinct, means they are all different objects. You don't have any repeated objects. And you have to take r objects out of it and you need to arrange them. So we have to select r objects out of n objects and then arrange them. How many such arrangements are possible? That is going to be your answer under permutation problems. Now here, as you can understand, out of n objects you are taking out r, right? Therefore, r should always be less than or equal to n. It can never be greater than n. So out of 10 objects, you can take 6 objects or 7 objects or even all 10. But you cannot take more objects, right? You cannot select 12 objects from 10 objects, which is not possible. So permutation is denoted as NPR. NPR or R permutations out of n objects, and the formula for NPR is n factorial divided by n minus r factorial. We will use this formula if r is less than n and NPR is equal to n factorial, if R is equal to N. So basically, if R and N are equal, here N minus R both will be equal, therefore it becomes 0. 0 factorial is 1. We have already seen it. So N factorial by 1 remains N factorial only. So if you are taking less objects, then you have N factorial by N minus R factorial. If you're taking all objects, all available objects for arrangement, then it is just N factorial will be the answer. So these are the basic formulas. Now we'll solve some questions. How many words of three distinct letters can be formed from the letters of the word land? They have given a word called land, and we are supposed to find a number of words that can be formed using these letters, and the word should have three distinct letters, means three letter words is what we are supposed to find. Always in such permutation problems, first identify what is N and R. Here N is 4, which is number of letters is 4, R is 3. How many letters you have to pick out of this and arrange? R is 3. So what is the answer here? Number of three letter words. Okay, number of three letter words is equal to NPR, which is 4P3. And for 4P3, we will write 4 factorial divided by 4 minus 3, which is 1 factorial, which is equal to 24. Now let us solve a very simple question. You can't expect this simple type of questions. You will have slightly complicated ones. We will solve one after the other. Now let us solve the next question. Suppose a license plate contains two letters followed by three digits with first digit not 0. How many different license plates can be printed? I think there is another version of this question. This question. First, we'll solve this question and then we'll take the other one. We will solve this question first. Suppose a license plate contains one or two letters, right? Okay, let me solve this one. Suppose license plate contains two letters followed by three digits with the first digit not 0. How many different license plates can be printed? So here what you have to observe is we have two types of characters to be chosen from. So we need to have first two letters, right? License plate should contain first two letters, and then it should be followed by three digits, which are going to be three different numbers out of 10 available digits. And the first digit should not be 0. Now here, let us not consider this first digit not 0 thing. If it is not there, if this particular restriction is not given, then the license plate will contain 5-digit, 5-character numbers. Out of this, these two are letters and these two are digits, right? And we have 26 letters, isn't it? So out of 26 alphabets, we can take any two alphabets for these two positions, which is going to be 26P2. So from 26 letters, we'll pick any two letters and we'll arrange that. That is given in 26P2 ways. Into, we have 10 digits. In that 10 digits, I can pick any three digits and arrange it here in these three positions, and that is going to be 10p3. Understood? Select three digits from this 10 digits and arrange them in the ascending order, in any order. Now here, why are we multiplying? Because it is not this or that. It is this and that. So I need both. I need two letters also. I need these numbers also. It's not just two letters or three numbers. Since I need both, I have to multiply them. So this is your example for multiplication principle. So two letters I will take out of 26 letters. Three digits I will take and arrange from 10 digits, and that is going to be the answer. So you can find out what is the answer, or you can even leave it like this. This many ways you can just directly write two letters out of 26 letters can be selected in 26p2 ways, and three digits from 10 digits can be selected in 10p3 ways. Therefore, total number of license plates that can be formed is 26p2 into 10p3. You don't have to actually simplify. You can keep it as it is. Okay. Now, here we have not considered this condition, that is first digit not 0. If we consider this condition, same thing like first two digits is letters, next three digits, but first digit cannot be 0. In this case, the first two letters can be filled in 26p2 ways, and then we have next three digits. In this three digit, first digit is not 0. Means for the first digit, how many options do I have? I have only 9 options, because from 0 to 9 we have 10 digits, and first digit, since it cannot be 0, I have 9 different options available. So there are 9 choices for this position, and then I am including 0 for the next digit, right? 0 is included for the next digits, but one of the digit we have already used. So excluding the number that is already used here and including 0, now I have 9 digits. Hope it is clear. Totally 10 digits are there. Since I cannot consider 0, in the remaining 9 digits, I have to take any one. So I have written 9 here. Now, after taking one of this non-zero number, I am left with 8 numbers. Plus, now I can include 0 for these two positions. So there are going to be 9 different numbers. From this 9 numbers, I need to choose any two numbers and arrange them for the last two positions. So this is your answer, which is 26p2 into 9 into 9p2. This will be the answer. You can simplify this and write, or you can keep it as it is. So this many different license plates can be formed. Is it clear, everybody? Any questions? Kindly mention your responses in the chat. That is the purpose of taking this live session. That makes it very clear for us also about whether the audio is clear, whether you're able to understand, so that we can proceed with the further questions. And in case you have any doubts also, you can mention in the chat section. I'm simultaneously reading the chat, and you will be your questions will be answered. Okay, so here we have used very simple questions under permutation, which does not have much restriction. Now let us take another example. From the digits 1, 2, 3, 4, 5, 6, how many three-digit odd numbers can be formed if repetition of digits is not allowed? Unless and until mentioned, we don't consider repetition of digits. Okay, so we always assume repetition is not allowed. In some questions, they would have specifically mentioned that repetition is allowed. Unless and until it is mentioned, if nothing is given, then we are going to consider that repetition is not allowed. Okay, so here they have given repetition is not allowed, which is basically the formula for NPR. So you don't have to bother about this not allowed thing. So here, what are digits we have? 1, 2, 3, 4, 5, 6. So how many digits are there? 6 digits are there. You are supposed to find 3-digit numbers. Are you finding any 3-digit number? No. It has to be 3-digit odd numbers. Only 3-digit odd numbers can be formed. Here, R is 3, but the answer is not 6p3. Okay, answer is not 6p3 because they have given we have to form odd numbers. Now, what is an odd number? So we have 3 positions. And what is an odd number? An odd number is the one which ends with an odd number, right? So how many odd numbers are there here? We have 1, 3, and 5. So for this 3-digit number to be an odd number, the last digit should be an odd number. Understood? So for the last digit, how many options do I have? Last digit. So the answer for this can be written as last digit. Make sure you are representing the answers properly. So you have to specify that last digit of for this 3-digit number to be an odd number, the last digit must be an odd number. So last digit can be filled, or you can say there are this many ways to fill the last digit, or you can mention last digit can be filled in 3 ways, because we have 3 numbers, right? 1, 3, and 5. One of this digit should be taken here. Therefore, there are 3 ways to fill the last position. And remaining 2 positions can be odd number or even number, doesn't matter. So first 2 positions, can be filled in. See, totally we have 6 numbers. In that, one of the number we have taken any number, say 1, 3, or 5, any number we have taken one of the number. Can we calculate by each position? Yes, definitely you can calculate by each position also. I'll tell you how to do that. So here, first 2 positions can be filled in using the remaining numbers. Now we have 3 digits. Out of that, one of them is taken here. Now we have remaining 2 numbers, and overall we have 5 numbers remaining, right? Because we have taken one of the digits here. So among those 5 digits, you will take any 2 digits and arrange it. Okay. Now you need to write number of ways of doing this task is equal to 5p2 into 3 ways. Why are we multiplying? Because we need this and this. So the last digit can be filled in 3 ways. First 2 digits can be filled in 5p2 ways. So the answer is 5p2 into 3, which is 5 into 4 into 3, 60. 60 different ways. Now when you have 5p2, every time you don't have to substitute the formula. Substituting formula is 5 factorial divided by 5 minus 2, which is 3 factorial, right? and then expanding it 5 into 4 into 3 factorial. Will stop here because we have 3 factorial in the denominator, which gives us 5 into 4, 20. So instead of this, what you can do is, whatever is R, write that many numbers from n in the decreasing order. So if I have 5p2, I need to write two numbers from 5 in the decreasing order, which is 5 into 4. So this is not any trick or something. We're just basically skipping few steps. That's it. So 5p2 is 5 into 4, which is 20 into 3 gives you 60. Okay. So suppose you have 7p3. You need to write three numbers from 7, which is 7 into 6 into 5. That's all. So if you have 10p2, write two numbers from 10, which is 10 into 9. So this is allowed even in your descriptive answers. You can write like this. So here 5p2 is 20 into 3. Totally we have 60 ways. Apart from this, we can also solve the questions in individual position basis, where we are not actually using the permutation formula, but we are using the multiplication principle. See here, we have three-digit odd numbers, right? 1, 2, 3. Last position must be 1 or 3 or 5. So we have three ways of filling this position, right? This is three ways. Here we need to have 1 or 3 or 5. So there are three ways of filling this position. So in this 6 digits, after taking one digit here, we have 5 digits available. So first position can be filled with any one of the 5 digits. So we have 5 choices. Now one number is taken here, one number is taken here, two numbers are used. So for in 6, if you have used two numbers, you have four more numbers remaining, and that four options you have for the second position, which is 5 into 4 into 3, 60 ways. So you can also solve it using position wise options. For each position, how many options you have, you take it and multiply all of them. That gives you the answer. And in this, you should know for which position you have to consider first. Whatever is restriction given, according to that, you need to choose which position should take the number first. If it is an odd number or even number, then you will first fill the last number, last digit, last position. Then you will consider how to fill the remaining positions. If it is something like the number should be greater than 2000, then if for the number should be greater than 2000, you have to consider the first digit. Okay, first digit cannot be 1. So accordingly, you have to first fill the first digit, then consider how to fill the remaining digits. Hope Sindhu Reddy, your doubt is answered. Okay, so this is your simple questions. We'll solve few more questions in order to. Huh. You might get questions of this type. Let's see how to solve this. Always, as I had told earlier, expand the bigger factorial until you get the smaller one. In this, n plus 2 factorial and n factorial, which is a bigger number? N plus 2 factorial is the bigger one, right? So expand this. So when you expand, first number to write is n plus 2. Next, you should subtract 1 from this, n plus 2 minus 1, which is n plus 1. Now again subtract 1 more. So from n plus 1, you subtract 1. That gives you n. Now I'll stop here because denominator has n factorial, which gets cancelled. And this is equal to 56. Now n plus 2 into n plus 1 is 56. You don't have to multiply these two. If you multiply it and then take 56 to the left hand side, it becomes minus 56. You will get a quadratic equation. You can simplify that and get the answer. Or in permutation and combination, there is another way of getting this value of n. That is, always these numbers are going to be continuous numbers only. See, whatever is n plus 2 and n plus 1, they have just a difference of one value, right? So find out two continuous values, which when multiplied gives you 56. So 7 8s are 56, right? 7 8s are 56. Two continuous numbers, which when multiplied gives you 56. You have to choose in this. See which is the bigger number. N plus 2 is the bigger number and n plus 1 is the smaller one, right? So write it as 8 into 7 equals to 56. It means n plus 2 is 8, which implies n is 8 minus 2, 6. So this is your answer. Solve for n. Value of n is 6. Now, in the next question, we have n plus 1 factorial divided by n minus 1 factorial. Here also, as I told you, start with the biggest number, n plus 1 factorial divided by n minus 1 factorial, which is a big number here. N plus 1 is bigger than n minus 1. So first write n plus 1. Now from this you subtract 1 and write n plus 1 minus 1 is n. Now subtract 1 more, which gives you n minus 1. Now see, I've got the same number as in the denominator. So we will stop further expansion and we'll write a factorial there and cancel these two, and this is equal to 12. Again here n plus 1 and n has just one value difference. So you know that this is 3 4s are 12 and bigger number you need to write first. 4 into 3 is 12. So it means n plus 1 is 4, or directly you can write n as 3. Therefore, n is equal to 3. Usually such questions might, how many three-letter words which has vowel in the middle position can be formed using letter of English alphabets? So you need to form three-letter words. So write down three positions, and which has vowel in the middle position. So middle position must be a vowel, right? So in how many ways can you fill this middle position? So there are 5 vowels. Therefore, there are 5 choices for that middle letter. So the middle position, or you can say second position, can be filled using one of the 5 vowels. So make sure you write the statements clearly, because see, you have 3 marks. This is a very common aptitude based questions actually. So if it is an aptitude question, this is how we solve. The middle position has to be a vowel, which is 5 options, and then for the other letters, they have not said that it has to be consonants. It can be consonants or vowels, anything. Okay. They've not mentioned middle letter must be vowel and the other letter must be consonants. That is not mentioned. So other letters can also be vowels or consonants. So therefore, one letter vowel we have used here, and then we will have out of 26 letters, one letter is used here. So I have 25 letters here, 25 choices, and then I have 24 choices here. So here like this you can take, and 25 into 24 is 600. 600 into 5 is 3000. So directly only this much will be required if it is a MCQ based question. But since this is a exam where you need 3 marks for this particular answer, please write the statements clearly. Second position can be filled using one of the 5 vowels in 5 ways. First and third position can be filled in 25 into 24 ways. All of you understood why 25 into 24? Because one letter we have used here out of 26 letters, and we have 25 letters remaining. So I have any of those letters I can choose here. So I have 25 options. And since now 2 letters are used, I have 24 letters to fill the third position. Here, should we consider repetition or not? If nothing is given, assume that there is no repetition. Unless and until they give repetition is allowed, we should always consider repetition as not allowed. So total number of 3-letter words you can form is product of all this. Number of 3-letter words is 25 into 5 into 24. I hope you understand why we are taking it in this particular order. For first position, 25 ways. For second position, 5 ways. And for third position, it is 24 ways, which gives you 3000. A very simple question, and you can get 3 marks. So this is also one of the previous year's question paper. How many numbers divisible by 2 lying between 50,000 and 70,000 can be formed from the digits 3, 4, 5, 6, 7, 8, 9, no digit being repeated in any number? First thing you need to find out whenever such range is given is how many digit numbers are you talking about? Okay, so sometimes you will have something like numbers between 5,000 to 20,000, suppose. In this case, you have to consider 2 subcases. One is solve as my question because it's helpful. Yeah, I'm trying to solve all the previous year's questions from this topic. Abdul. Okay, what is your subject code? So 5,000 to 20,000. So these numbers are 4-digit numbers, right? So from 5,000 to 9999, we have 4-digit numbers. And then from 10,000 to 20,000, these numbers are 5-digit numbers. So we need to consider how many 4-digit numbers are possible and how many 5-digit numbers are possible also in this given range. Then you need to add it. So always make sure whenever a range is given, find out the digits that are there in between that range. In this case, between 50,000 to 70,000, all are 5-digit numbers only, right? 1, 2, 3, 4, 5. So you are forming 5-digit numbers. 1, 2, 3, 4, 5 positions to be filled. And the numbers should be divisible by 2. What does it mean? It must be an even number. So for this number to be divisible by 2, that is if it has to be an even number, the last digit must be an even number, right? In the given digits, how many even numbers do we have? 4, 6, 8. there are three even numbers. So basically, the last digit must be either 4 or 6 or 8. If we put any other digit, that is 3, 5, 7, or 9, it becomes an odd number. So make sure that the last digit can be filled in three ways. Now, for the remaining digits, do we have any restriction? Yes. First thing is number should be divisible by 2. Therefore, I have considered an even number here, which is 4, 6, and 8. Now, the number should be greater than 50,000 and it should be less than 70,000. Therefore, the first digit over here can be, it cannot be 3, because if it starts from 3, the number will be 30,000 plus. It cannot be 4, then it will be 40,000 plus. So the first number can be 5, or it can be 6, or it can be, that's all, only 5 and 6. Only 5 and 6 are possible here. Because if it starts from 7, then the value is going to be greater than 70,000, right? Because you see, we don't have zeros. Suppose I have something like this, then it is greater than 70,000. It has to be 50,000 and 70,000 range only. Therefore, the first digit cannot be 7. Okay, first digit must be 5 or 6. But here, 6 is also a possibility for the last digit. So whenever there is a digit that occurs in both first digit as well as last digit, you have to consider it in two ways. What are they? Consider 6 in the last digit separately and consider 6 in the first digit separately. We have two ways of solving this question. So hope you have understood whatever explanation is given now so far. So what we do is numbers ending with 6 and numbers not ending with 6 we will consider. Because if the numbers has to be between 50,000 and 70,000, then the first digit must be 5 or 6 only in this given range. Okay. So the answer is presented like this. Given numbers or given digits are 3, 4, 5, 6, 7, 8, and 9. Okay. Now, numbers, required numbers, or you can write numbers in the range 50,000 to 70,000 are 5-digit numbers starting with 5 or 6, right? 5-digit numbers starting with, so instead of taking ending digit, you can also take the starting digit, starting with 5 or 6. So from these digits, the number cannot start with 3, cannot start with 4, and it cannot start with 7, 8, 9 also. The starting digit should be either 5 or 6. Only then it will be in the range 50,000 to 70,000. So in how many ways can you fill the first position? So we will find out numbers starting with 5. Okay, numbers starting with 5. So if the number is starting with 5, then first position is fixed, isn't it? Number starting with 5 will be of this format. 5 is there here, and you have 4 more digits to be filled. First position is fixed or is filled with 5. Remaining positions. So totally how many digits we have? Remaining positions are filled in, we have 1, 2, 3, 4, 5, 6, 7. 7 digits are there. Out of this, 5 is taken here And in the remaining digits, I have to put even number in the last digit, right? So last digit can be either 4, 6 or 8. 4, 6 or 8, right? So write down this last position also. First, you have to write the last position. Last position is filled with 3 ways. There are 3 choices to fill the last position. And now remaining positions. How many positions are remaining? First position is fixed with 5. Last position, we have 3 ways of putting either 4 or 6 or 8. So we have chosen one of the numbers. So 2 numbers are already taken. Now I need to fill only remaining 3 positions from total 7 numbers from this 2 numbers are taken. So I have 5 numbers. And from that 5 numbers, I need to choose any 3 numbers and arrange them. Is this clear, everyone? So understand here carefully. The number should be between 50,000 and 70,000. So the number should start either with 5 or with 6. Now let us consider how many numbers starts with 5 and how many numbers start with 6. So first I am considering numbers starting with 5. If the number is starting with 5, means the first position is fixed with 5. Now for the last position, this has to be an even number, right? Because the number should be divisible by 2. So since it has to be an even number, the last digit must be either 4 or 6 or 8. So there are 3 ways of filling the last position. Now first position is filled, last position is filled. So out of 7 available digits, we have used up 2 digits. So there are 5 remaining digits. Out of them, you need to pick any 3 and arrange in these 3 positions in 5p3 ways. So the total numbers are, so number of such values or numbers are 5p3 into 3 ways. So 5p3 is 3 numbers from 5, which is 5 into 4 into 3 into 3. What do you get here? 20 into 9 is 180 different numbers are possible that starts with 5. Now we will consider numbers starting with 6. Now if a number is starting with 6, then how many options do we have for the last position? Number is already starting with 6. We have 4 more positions. And since this has to be an even number, for the last position, you must have an even number and the digits are not repeated. In 4, 6, 8, 6 is already present here. So the last position can be filled with 4 or with 8. So we have two available options only. So you have to write the answers in this in this format. I am just writing the answer here. You need to mention it this way. First position is fixed with 6. Last position is filled with 2 of the remaining digits, which is 4 and 8 in 2 ways. Now, first position is fixed, last position is fixed. Out of 7 numbers, we have used 2. So we have 5 remaining numbers. Out of that, you need to take any 3 and arrange this remaining 3 positions. So the answer is 5 into 4 into 3 into 2 ways. Okay, which gives you 20 into 6 is 120 ways. Now I have 2 intermediate answers. What that is? Numbers between 50,000 to 70,000. Numbers that are starting from 5 are 180. Numbers that are starting from 6 are 120. So total number of 5-digit numbers that are divisible by 2. So 5-digit numbers divisible by 2 in the range, write that entire statement, divisible by 2 in the range of 50,000 to 70,000 are. Now should we add this or multiply this 180 and 120? Add or multiply? So we have to decide whether it is this or that, or this and that. Now what is 180? It is number of 5-digit numbers that starts with 5. And what is 120? It is a number of digits, the number of 5-digit numbers that starts with 6. Can a number start with both 5 and 6? No, right? It has to be either starting from 5 or from 6, right? Therefore, it is or. Therefore, we have to add them. So 300 different numbers are possible. Ragesh, yes, add. Abdul, no, not multiply, because the numbers should be between 50,000 to 60,000, right? It has to be any number that you form. Either it's going to be a 50,000 plus number or 60,000 plus number. Okay, so we need to add them. Hope it is clear. Just to be very clear with that adding and multiplying, that is very important. This carries 3 marks. We have another question which is also of permutation only. From digits 1 to 6, how many 3-digit odd numbers can be formed when repetition of digit is allowed, repetition of digit is not allowed? Here there are no restrictions. No, we have restrictions. That is 3-digit odd numbers. We need to form odd numbers. So the last digit must be an odd number. So what is the first option? Repetition is allowed. Okay. So that is with repetition. How many values are there? N is 1, 2, 3, 4, 5, 6. There are 6 digits given. And we are supposed to form 3-digit numbers. When you form 3-digit numbers, you can actually consider whenever repetition is allowed, we don't use the NPR formula. We have to consider each digit separately. Now the last digit can be filled since it has to be an odd number. Last digit must be 1, 3, or 5. Okay, so for the last digit, we don't have all the numbers as the options because it has to be an odd number. It should end with an odd number, and we have only 3 odd numbers here. So I have 3 ways of filling the last digit. Now, since repetition is allowed, whatever digit I have used for the last position is also available for the first and second positions. So I have 6 different options for the first digit and 6 options for the second digit, first and second digits, which is 6 into 6, 36 into 3 is 108 different numbers can be formed using the 108 different odd numbers can be formed using the given 6 digits. Okay, this is with repetition. Without repetition is, that is repetition not allowed. Here also, why are we considering the last digit first? Because they have given that it has to be an odd number. Now last digit can be filled with any of these three digits. So they have three options. And now after filling one of these numbers here, either 1 or 3 or 5, one of them I'm going to put it in the last position. After that, since the digits are not repeated, whatever number I'm filling here is not available for as an option for other digits, other positions. Therefore, one digit is used here. So from 6, one of the number is used up here. So I have 5 options for the second digit, and after two numbers are used, I have 4 options for the third digit or the first digit. So which gives you 20 into 3, 60 ways. Okay. Here see, we are not adding this because these are two different questions. And again, just don't write this much. You have to write statements like this. Okay. So here we have seen numbers that are given, and then we are supposed to find how many 3-digit numbers or 4-digit numbers can be formed. And we have considered odd numbers and even numbers or numbers in a specific range, which is basically applying restriction for the numbers that can be used in the first position and in the last position. So if the numbers have to be between 50,000 and 70,000, we had to apply restriction for the first position. And since the numbers should be divisible by 2, we have to apply restriction for the last digit also. Whereas in this one, since the number must be an odd number, I need to apply only, there is no range given. So I have to apply condition only for the last digit. Accordingly, we find how many arrangements are possible. So the next type of question is where we have together and not together arrangements. Together and not together arrangements. So basically here you will get questions in which there are certain people who are sitting together such that these two people are always together, or this particular subject of books are always arranged together or not together kind of questions. So let us first find out how to solve questions of together category. Okay. So together questions. So whenever you have together questions, don't write the value of n in this both together and not together type of questions. Don't count given n, given number of digits, and that is not your n value. Okay. For together questions, always, whichever objects are supposed to be together, all those objects are considered as one single unit or one object. Okay. So consider objects that are supposed to be together. Okay. Objects supposed to be together as one object or as one unit. So whenever you are rearranging, you are taking that entire unit and rearranging. So assume that it is an box. Okay, assume it is a box, and you have all these values present in that box, whichever is supposed to be together. All those things you're putting in that box. Now, whenever you are rearranging it, you're keeping the entire box in the other position. Therefore, those letters or those objects are staying together. But within that box, the objects can be arranged as well, right? So always for together kind of questions, count n after considering the objects objects as one object, then you count the value of n. Then the answer is going to be, so then you count n, okay? So the answer for these type of questions is going to be n factorial into number of objects grouped as one unit, that factorial. What is n? It is the number of objects counted after considering the together objects as one particular object. In how many ways can 5 Telugu, 3 English, and 2 Hindi books arranged on a shelf if books of each language are to be together? Now, which all objects are supposed to be together? Group all that as one object. So totally we have actual total number of objects is 5 plus 3 plus 2, which is 10 books, right? But we will not consider this as a 10. N is not taken as 10 here. Whenever you have this together, count whichever is supposed to be grouped or whichever is supposed to be together, you group that as one object and then count. Now I have 5 Telugu books, right? So these 5 Telugu books are considered as one object. These 3 English books are considered as one object, and 2 Hindi books are considered as one object. So basically n here is 3. Okay, I have 3 objects. So number of arrangements possible is first, after grouping them, we have to count the value of n. Now take n factorial. N factorial is 3 factorial into, in each of these groups, how many objects we have grouped, that factorial you have to take. So here I have grouped 5 objects. So take 5 factorial into. Here I have grouped 3 objects. So take 3 factorial into. Here I have grouped 2 objects, which gives you 2 factorial. Now simplify this. 3 factorial is 6, 5 factorial is 120, and this is 6, and this is going to be 2. So you get 12 into 24. It is 8640. So 8640 different arrangements are possible, right? University always together, right? Now suppose you have a word. Okay, so find number of arrangements. Find number of arrangements of the following. The first one is Monday. Letters of the word Monday. So here I have a word and we are supposed to use all the letters of this word and find out how many rearrangements are possible. So here n is 6. When we say number of rearrangements of all the letters of the following words, all these letters we are taking for rearranging. So what is the formula that we considered when we have to take all the letters? If we are taking R is equal to N, If r is equal to n, then the formula is n factorial, right? If you're taking all numbers for arrangement, the formula is n factorial. So here n is 6. So number of arrangements of these letters of the word Monday is 6 factorial, which is 720. Now suppose I consider I need to arrange the letters of the word Monday such that vowels are together. Okay, vowels are always together. So here what I need to do is, how many vowels are there? All those vowels, we need to group them as one single object. Here I have O and A, right? O and A, these two vowels are there. We need to group them as one single object. So first rewrite this word by writing those two letters together and then count n. Or you can count like this also. So write like this, MNDY and then OA. So these two vowels are supposed to be together. I am writing them together and marking it as one box. Now I'll find out what is value of n. It is 1, 2, 3, 4, and this is taken as 1, which is 5. Or we can, instead of rewriting, we can also count, mark the number of letters that are supposed to be together. Okay, mark all the letters that are supposed to be together. Now count all the remaining letters. What all letters we have? M, N, D, Y. So I have three letters, right? So you can write N is equal to M and D, Y, four letters, plus all the marked letters are taken as one object, therefore 5. So either you can rewrite and then count, or if you don't want to rewrite, if some words are, lengthy words you don't want to rewrite, then mark the letters that are supposed to be together. Count all the remaining letters. And then since all the marked letters are supposed to be together, you count them as one object. So 4 plus 1, 5 is the number of letters. Now, how many arrangements are possible? Number of arrangements. So if I have n letters, the number of arrangements is n factorial, right? So if I have 5 letters, the number of arrangements is 5 factorial. But here in one of the unit I have considered, we have, yes, you can take calculator to ignore exams. Okay, so this 0, O and A is considered as one object, right? So that we have to take the factorial of that. There are two letters. How many letters you have written here? That factorial you need to take, which is 120 into 2, 240 different arrangements are possible. Okay. So we have seen a letter, a number, sorry, a word where we have rearranged all the letters without any restriction. We have seen a word where we had some restriction that it should contain some particular letters should always be together, and accordingly we have counted the value of n and we have found the number of arrangements. Now what if we have a number of arrangements in which the letters are not together? This is for together, very simple. So just count which all supposed to be together, mark it, count remaining number, plus 1 is the total number of objects, or this is in case you have only one group. In this case, you see we had 10 books, but there are 3 different groups. You can have multiple groups also. Whichever objects are supposed to be together, you mark it as 1 and consider that as one object. Now you count the value of n. Write this factorial into how many ever objects you have marked as one unit. Each one individually you take the factorial and multiply. Okay, this is for together questions. Now, if we have not together questions, not together. When the objects are not supposed to be together, again here we divide the available number of objects into two groups. There are two ways of solving this. First method is applicable only if not together objects are equal to 2. Okay, method 1 used only when not together objects means number of objects which are not supposed to be together is equal to 2. Okay, if we have two objects which are not supposed to be together, only then this method 1 will work. So what is this method 1? So number of arrangements in which the certain given two objects are not together is equal to, so number of not together arrangements is equal to total arrangements. Find out total arrangements without any restriction. From this, we need to subtract together arrangements. That gives you not together arrangements. Okay, from total arrangements, you need to subtract together arrangements. That gives you not together arrangements. See this previous example. We had a word Monday, which has 6 letters. We found out how many different rearrangements are possible. These 6 letters can be rearranged in 720 different ways. In this, we found out in how many arrangements O and A, that is, these vowels are always together. So now vowels are together in 240 arrangements, right? Out of this 720 arrangements, in 240 arrangements, the vowels are together. It means in the remaining arrangements, vowels are not together. Simple. Okay. So here, if I have the word Monday and vowels are not supposed to be together, Monday is the word in which we need to arrange the letters such that vowels are not together. So what we do, we first find out total arrangements. Okay, so solution for this is find out total arrangements. For total arrangements, we consider n as 7 and 6, sorry, and we have to take the factorial of that, 6 factorial, which gives you 720. And then from this, you subtract together arrangements. So how many together arrangements are there? You mark vowels, count remaining numbers, then plus 1, which gives you 5, right? Yeah, 5. 5 factorial into 2 factorial. How many letters you have grouped as one object? That factorial, which gives you 120 into 2, 240. Now, what is not together arrangements? Subtract together arrangements from total arrangements. Okay, which is total arrangements is 720. From this, you subtract 240. You will get 480 different arrangements in which vowels are not together. This is one way of solving not together questions. This method is applicable only if the number of objects which are not supposed to be together is 2. Okay. And then we have second method, method 2. What is this method 2? if the number of objects which are not supposed to be together is greater than 2. So not together objects means number of not together objects is greater than 2, then method 1 will not work. I'll tell you why. Now, what do you mean by together minus not together? Uh, used for not together objects greater than 2, but it is applicable for all, like the previous question Monday, where we have solved. Even for that, we can use this. So this method 2 is applicable for all, but we mostly use whenever not together objects is greater than 2. But method 1 is applicable only if number of not together objects is equal to 2. Okay, now let's take an example. Example is computer. I'll take the word computer. Here, let us first find out total arrangements. We don't need total arrangements because we know that it is not going to be equal. So we'll find out the number of arrangements of computers such that vowels are not together. So when I say vowels are not together, even two vowels should not be together. There are three vowels, even two vowels should not be together. Okay, so how to solve this? Now here you divide the data into, divide the given letters into two groups. So here we have, we divide, write the statement properly. We divide the given letters into two groups. Group 1 is without restriction, means letters which does not have any restriction. These letters will write it as group 1, which are C, M, P, T, R. For these 5 letters, there are no restrictions. What is group 2? It is the number of letters with restriction. With restriction. So what is the restriction? O, U, E. So what is the restriction? They're not supposed to be together. That is the restriction. And the number of letters which are not supposed to be together is 3. So this I will take it as N1, which is 5. This I'll take it as N2, which is 3. Number of objects which are supposed to be together is 5. Number of objects which are not supposed to be together, sorry, number of objects without restriction is 5. Number of objects which are not supposed to be together is 3. So this we will take it as N1 and this is N2. Now arrange these letters which do not have restriction, arrange them in N1 factorial ways. Okay, we have 5 letters. Now the consonants, so you can write the answer like this. Consonants are arranged, 5 consonants are arranged in 5 factorial ways. So we have 5 letters and 5 positions. So number of ways of arranging this is 5 factorial into, so the answer is N1 factorial. That is number of objects which do not have restriction. First rearrange them. Don't consider these vowels, just take these consonants and rearrange. So that can be done in N1 factorial ways. Now with this, there are alternate positions, right? Check how many alternate positions are there. Have 1, 2, 3, 4, 5, 6. There are 6 alternate positions. Always the number of alternate positions will be 1 greater than the number of objects that is being arranged. Here we have arranged 5 objects. Therefore, there are 6 alternate positions. If you arrange only 3 objects, you will have 4 alternate positions. Okay. So we have 5 objects here. Number of alternate positions will be n1 plus 1. How many objects we have arranged here? Plus 1 will be the number of alternate positions. In this, we are going to pick this many objects, 3 positions, and we are going to arrange these 3 letters in those positions, which is n2. Remember clearly, if this n1 and n2 is confusing, you can write it as m and n. Number of objects without restriction, we will take it as m. Number of objects with restriction, you will take it as n. So the answer is m factorial. That is, without restriction objects, you first arrange it, and then there are plus 1 alternate positions. In this, we will pick n positions and we will arrange the letters. Okay. It is m factorial into m plus 1 pn. Now, how to write it? Consonants are arranged. Consonants can be arranged in 5 factorial ways. Consonants, 5 consonants can be rearranged in 5 factorial ways. Okay. 3 vowels can be arranged in one of the in 3 positions out of 6 alternative positions. So how many alternate positions we have? Since we have 5 objects that we have arranged, there will be 6 alternate positions. Okay, alternate positions in 6p3 ways. Now, do we have to add this or multiply? Since we need to arrange consonants and vowels. So number of such arrangements is equal to first 5 factorial into 5 is there, no, plus 1 you have to write, which is 6. P, how many letters are there which are not supposed to be together? That one you have to write. This gives you 120 into 6 into 5 into 4. Is that clear? In the alternate positions, you have to fill in. So now what do you mean by this filling it in the alternate positions is, see, these 3 letters are not supposed to be together, right? At least 1 letter must be there in between them. We can have more than 1 letter also in between them. Now, if I have 3 letters to be filled and I need 3 positions for this, let me take, this is the first position, this is the second position, and this is the third position. Suppose. Now, between first and second position, I have 2 letters, right? Between second and third vowels, not positions. Between first and second vowels, I have 2 letters. Between second and third vowel, I will have 1 letter. So basically, they're not together. So I can take first is this, second one, and then this position. Now between every pair of vowels, there are 2 letters. So take any 3 positions out of this alternate position. They will definitely have at least 1 consonant between them. That is the concept of choosing n positions in this alternate positions. Is that clear? So alternate positions will always be plus 1. So this is 20 plus 20 into 6, 120. 120 into 120 is 144, 00. This many different arrangements are possible in which vowels of this word are not together.
वीडियो अच्छा लगा हो तो इसे लाइक और शेयर जरूर करें। आपके लाइक्स और कमेंट्स हमें जल्द वीडियो बनाने को प्रेरित करते हैं।